Yeah. Now we are on the air. Hello, everybody. This is Mike Riley, and welcome to the Lunar Network's Hangout. This is part of the Deep Space Information Special Interest Group, and with me today we have Abraham Vassant of Flexure Engineering and Pamela Clark of Catholic University of America. Pamela is an expert on the planetary sciences, and she's here with us today to discuss putting lunar cube technology to use around the moon. So Abraham, why don't you say hello, and then we'll go right to Pamela.
Hi, every viewers. We're back again, weekly basis, and we're glad to have this hangout with Pamela today. Pamela, now it's your turn.
Okay. So I'm not sure what you want me to talk about. If you want to talk about the space SIG, I can talk to you a little bit about the space SIG. And if you want me to talk about what the design challenge is going to be like that you're going to be running, I can talk about that. The space SIG, the idea behind the space SIG, that's actually short for small payloads and advanced concepts for exploration, was to bring together scientists and engineers to form collaborative teams to propose CubeSat missions. And that was kind of the bottom line. Actually, there's steps in between there. One of the bridges is instrumentation. So the idea is basically to let the science people know what's out there that could potentially support an instrument package, and even what kind of technologies are available for the instrument package itself. And the idea was to get people to talk about their current developments or their current notions for what they would like to do, and to have other people from the team work with them. You know, one of the issues is that people don't necessarily like to share because everything's become so competitive. So it quickly became apparent that there were a lot of people that felt they couldn't really say very much without a non-disclosure agreement. That's a problem. I don't know how to get around it. I only know one way to get around it. And that is if people feel that it's worth their while to share because they're going to get something more worthwhile in return. And the best way I can think of to do that is to connect this directly from things that happened during the LunarCubes workshop in terms of follow-up. So one of the ways I tried to design the design challenges this time was to build in an overarching question and specific follow-up areas that could come out of the design challenge. So in the meanwhile, in the interim, I just stopped doing the design challenges because we weren't getting enough people involved. Now, one of the things that's actually changed in the last several months is that NASA finally released an opportunity for subsidized launch to deep space. And as a result of that, there are now a lot more people thinking about deep space CubeSats. And as a result of that, and for the first time in the workshop, LunarCubes workshop, we got twice as many abstracts as we could put on the program. This is a very good sign. And it may mean that one of the things that was really lacking in the SIG was full participation of scientists, because you're not going to get engineers to come to the table and share their expertise unless they feel that there's something that's really interested. So with the science people plugging in, I think that changes the dynamic. As far as the design challenges, one of the things I'm trying very hard to do is to make sure that everybody has the questions in advance, including people who are just participating. And we're going to start off with a relatively structured design challenge on Tuesday morning to get things going. Now, normally have a very hard time sort of integrating the science, essential science needs translated into science investigations and to create a kind of groundwork so that the engineers kind of know where there are special needs to make something happen. And we're going to start off with a particular case study. It's actually already been done by students at Embry-Riddle University. So that's going to create a sort of model, if you will, for looking at how you can translate science requirements into mission concepts at maybe a naive level, or not. I don't think it's completely naive, but it's interesting that these folks have been dealing pretty much extensively with the official Mars folks at JPL who are not used to thinking about CubeSats, to say the least. I mean, their thinking is actually pretty big, so it'll be interesting to see what happens. Now, on Thursday, at the end of the day, that's your session and design challenge, and at that point, you know, we will have talked about interesting science investigations, subsystems development, what is still unmet. You know, there's still some major challenges, you know, in engineering to support the kind of science we want to do and the kind of environments we want to be in, and that's going to be discussed on Wednesday. And then, but we have talked about part of the infrastructure, which is the transportation infrastructure, on Thursday morning. So that, and so one of the things that's left, which is a still big issue, is communication. How to set up an infrastructure to support communication in space. So, you know, what I see this as cumulative. I'm fully aware that not everybody's going to be there every day, but on the other hand, we kind of are moving through this process and building on what we already know. And so at that point, we will have kind of laid the foundation for understanding what the technology that's out there is, where it's going to go in 5 years, what the interesting science challenges are, the kind of targets people want to go to. And we will have talked about various options for transportation, getting to where you need to go, and that's going to leave comm, which is still, you know, still unresolved. And I tried to get somebody who's working on this really compact laser comm system that I kind of stumbled across, but it was too late to get them to come to this workshop. I could probably get them to come to the next one. But the problem with laser comm, of course, is that there are really no laser comm receiving stations to speak of. So that leaves a lot of stuff involving kind of infrastructure in your camp. And of course, when you talk about comm, you're talking about everything, because all of the control stuff, you know, in terms of navigation, tracking, you know, anything that now involves the external use of resources, which typically involves comm, I mean, that the whole business about onboard autonomy affects it directly. And of course, that affects how you're going to do your comm and what kind of networks you're going to use. And so that's kind of where you guys come in. So as long as we can get the audience engaged in an interaction to discuss this, the specific ways we get to that point, I don't really care very much about. I just created the, you know, design challenge questions as a kind of jumping off point. We're going to get more deeply into some areas than others, and one particular area of interest may dominate the entire hour. That's not a bad thing, because we'll just use the SIGs to kind of follow up. That's how I look at it. So that's my thinking. Anything else? I mean, you want me to talk to you about what's going on with Deep Space CubeSats right now? One of the big breakthroughs, I feel, is that NASA has finally, by default, expanded the CubeSat Launch Initiative program, which is the subsidized launch opportunities, to include things beyond low Earth orbit. I have that directly from Garrett Scrobot. And that is not, this is new, because I asked him the same question last year that I did this year. And this year, and last year, he kind of said, well, you know, it's kind of not on our plate. And this year, he said, yeah, well, we already have 2 CubeSats that want to go beyond low Earth orbit. So they're looking for, you know, more people to request to be manifested, basically apply to this program. And the nice thing about it is that it's essentially subsidized launch, which is usually a big part of the cost. And NASA acts as the broker, because the launch providers do not want to deal with individual customers. They want to deal with a broker. And as far as what's going on within the science community, well, because NASA finally opened up opportunities to propose for deep space CubeSats for subsidized launch, and for whatever you had in mind to be released from EM1, it's changed the environment dramatically. I mean, the thing that hasn't happened yet, unfortunately, is that Planetary is supposed to be releasing a similar opportunity, has not put the opportunity out on the table. Heliophysics did. Heliophysics put out the H-Tides opportunity to do compact instrument package development. They had an option to apply for the slots on EM1. And at this point, NASA SMD has 3 slots, not 1. So it's completely game-changing. And everything's, and as a result, I think as a direct result, people have started to take the deep space CubeSat stuff seriously, and things are even happening here at Goddard. Even though Planetary hasn't released the AO yet. It's a hell of a lot harder to fly CubeSats in deep space. The challenges are still there, and they're still not the potential answers, which of course anybody who wrote a proposal had to come up with, are far from being proven. I mean, I can look back at our proposal. I was involved in 2 proposals for H-tides, and I can say, oh my God, how are we going to do this? How are we going to do this? I mean, I know I've already talked to people on the team. I thought, somebody must have thought about this. Did you think about that? What about this? No, I really haven't thought about that yet. I mean, there's lots of stuff. I mean, one of the ways it's going to be very difficult, it's going to be really difficult to close the gap in terms of communication, because the technology we have now is barely capable, and it's basically the JPL X-band iris transceiver and dual X-band patch antennas. And that's what's on the table, because there's nothing else that's been developed yet. It's the only system. And I mean, nobody wants to fly a high-gain antenna because you use up a whole U just to stow it. And then when you have it attached to it, and when you've deployed it, and it's hanging off the side of your CubeSat, it's just generally bigger than the CubeSat itself, it becomes a real bear to control it in terms of attitude control. It makes it very tricky. So it's really not an answer. So I'm hoping that they make some progress on LaserCom. This is a group called FiberTech. They're actually located there in Virginia, I think. So I'm convinced that we're going to get the propulsion stuff. We're going to solve the propulsion problem this time, because I would imagine that virtually everybody who put a proposal in is working with somebody to do the propulsion. And you need at least 1 km/s delta V if you're going to get anywhere near the moon. So that means everybody's working out with a propulsion system that's never been built before. I have my personal favorites based on what I know and the partnerships that we formed in the 2 different proposals I was involved in. So I actually we actually have 2 different groups that are going to be talking during the LunarCubes workshop on propulsion. And they have very different approaches to propulsion. So. And the other big area is instrument development. We have a real lag in the development of compact instruments that are sufficiently capable and can still fit within a very compact form factor to provide the kind of measurements that people want. And one of the things that makes the coming up with a standard platform tricky is that depending on the kind of instrument that you have, not just the size, which we're going to work on getting smaller, but depending on the kind of instrument you want, the needs you have can be considerably different in terms of what you want your onboard systems to do for you. And the placement can be very different depending on what kind of measurements you're taking. So there'll never be the kind of uniformity probably in deep space CubeSats that there has been in LEO CubeSats. I'm not really too uncomfortable with that. I figure if we can, it's likely that even though they're going to be more complicated and require more variation, that if we can get I think we can get the costs down by probably a couple orders of magnitude on an individual CubeSat. And if we fly multi-platform concepts, which nobody's letting us test out yet, by the way, so it's not a level playing field for CubeSats yet because we're doing pathfinders. It's hard to compare a little tiny CubeSat with a great big flagship mission and not come up short. The beauty of the CubeSats, of course, is a multi-platform concept. So when we begin to look at multi-platform concepts, we can do a lot more distributed measurements, and then maybe the gap will be an order of magnitude because we'll build lots of these things and just dump them out, and that'll all, they'll basically be the same. It'll be economies of scale. So we're not there yet, but that's where I see that's the potential. So in 5 years, I think it'll be really different in terms of what kind of missions people will be thinking about. Although, there's still a lot of hangers-on to the old paradigm because people have built their careers and their lifestyles on the old paradigm that's 40 or 50 years old now. And they're very reluctant to give it up because they enjoy a lot of power. However, it doesn't matter because there's no money to fund that paradigm anymore. So they're in the way. So it's just a matter of trying to get them out of the way. And if there's enough excitement generated by what we can do with CubeSats, and the kinds of places we can go and the kind of measurements we can get, then I'll just be, I'm liking my little vision of seeing people just kind of standing there on their committees that have been dictating how we're all going to be getting a few crumbs for the last 40 or 50 years, just becoming completely irrelevant. And I have to go in about 5 minutes. I got to get over to a meeting at 3. So.
We've talked about a lot of technology drivers and science drivers. Where are we going to get the funds or the direction to push the technologies forward?
Well, there's the SBIR process, which under this administration has been seriously curtailed, I admit. But I'm hoping that it won't continue indefinitely. A lot of the small startups that are developing technology that's now being used in CubeSats have gotten their start with SBIR funds. And then what's happening is that resources are being shifted within programs into CubeSats. So it's happening really slowly and with difficulty in Planetary because that paradigm dies hard. But in other parts of NASA, it's already happened that they've shifted a fair amount of resources into the small sat CubeSat realm, and it will happen in Planetary too. One of the things that has to happen that I didn't talk about and make this happen, 2 weeks ago there was a NASA electronic parts and packaging workshop, and these folks are looking at the component level, and they're looking at how to get essentially inexpensive parts that are also capable of dealing with extremely rugged environments where you need to have thermal and radiation protection in deep space. And one of the things that needs to happen, it isn't just the parts themselves. There's some challenges that are social in nature or political in nature. One of those is the best place to get reliable parts is from the folks that make lots of them, and they have a good reputation. And they make lots and lots of these parts, and they have big customers. The problem is that NASA's not a big customer, so it's hard to be able to make reasonable deals for parts from the people that are probably the most reliable sources. The other issue is technical in terms of figuring out a paradigm to use that's completely different from the one that we use for Class A missions to develop CubeSats. People have thought about several ways to do it, and it's a matter of what's going to work best and solving the part supply problem. A lot of parts that are used are actually automotive parts. I didn't know that. And the other ones, to some extent, consumer electronics. Not DoD stuff, which isn't in the right form factor, and not medical stuff, which is actually fairly expensive.
For the CubeSat technologies. I know you only have a couple of minutes, but your mention of parts brings up a question for me, and it also ties into some things that are happening right now, something that's in the news. Elon Musk has launched another rocket up to the International Space Station, and it's carrying on board a 3D printing device, from what I understand. How might that play into deep space cube technologies?
I think that's the Made in Space folks. I think it's their 3D printer. I think they were the ones who. I think that's where that came from. Well, yeah. What they're doing is, that's the ultimate goal, isn't it? Then you would have to get rid of the transportation infrastructure. Basically, you put your 3D printer within probably 5 or 10 years, they'll be able to print virtually anything. Now they can't print anything. The big goal, the next goal, is to be able to print basically electronics boards. But at this point, they can print a lot of stuff. They can print a lot of different materials. So the goal is to make everything. Everything from soups to nuts. Everything from the detectors to the boards, to the exotic metals, metal parts,
All that space.
and to be able to do that in any environment. Now you have to have an infrastructure to do that, because you're going to have a network of these, and they have to be maintained somehow. So the question is where you want to put these things. But if in fact you have that, then you've got the basis of an infrastructure, a sort of a manufacturing infrastructure in deep space, and that would be great. Yeah, I mean, just build in place.
Pamela, I want to just add in one more input from our recent visit to the space systems of Laurel and Moog. These are private in the space industry people. And what is interesting to note from SSL, the Space Systems Laurel, is they have a huge stream of orders which put huge satellites in geo orbit. And currently they're doing about 5 to 6 a year. In 10 years, they seem to think it will go up to like 7 to 8 per year. So that was, and it has, they showed a empty space which is about 30-40 liters in capacity, and they have not specifically defined anything unique or like a pod deployment, but they have the interest and willingness and a price tag that they're able to take any payload right up to geo. So that was one. And secondly, with Moog, it's the thought of that ARC-50, or like Russell refers it as a TAPS project. So that also is likely to develop in our own version of a reference platform, but not necessarily they will endorse it or use it. But they have similar program in their own agenda. So they are extremely excited to work with us specifically on the ARC project. Okay, so that's two things I wanted to say.
Great. Okay, so I gotta go.
Yeah.
Thanks for coming out. Glad to have you on board.
Okay.
We'll have you again soon.
Yeah. Okay. Bye.
Thanks. Take care.
All right.
Well, there you have it. A quick briefing from Pamela Clark, Catholic University, and also sitting at NASA Goddard Space Flight Center.
See you all next week.
Okay.